Okay, so hopefully the quiz went okay. We'll take a look at it. I'll go over it. Then we'll do some more probability problems, and then we'll look at the project one. And just to let you know, this is going to be a bit shorter than usual. I'm giving a statewide presentation on how to adopt free textbooks for students in at 3 o'clock, and I got to be online 10 minutes earlier. So expect this to be a little shorter than usual because I think that's important. Okay, and what I've heard from my colleagues is most of them aren't using their full time anyway, but I think I should, if I can. So let me share my screen. Okay, so let's take a look. And what we got is a bag contains 42 marbles, such that 15 are blue. So I like to just write down all the info we've got. And I'm going to do that as we talk because I think it's good. So we have 42 total, 15 blue. We have 18 yellow. And the rest are red. How do you figure out how many reds there are? And the idea is it's not that hard, it's not that technical, but you need to be able to do that. So how do you figure out how many reds there are based on that first sentence?
Just add 15 and 18, subtract from 42.
Exactly. You just do 14 minus 15, 42 minus 15 minus 18. 18 plus 15 is what, 33? So 42 minus 33 is 9. So there's going to be 9 reds. Okay, then 5 of the blue marbles are spotted. So of the blue, we have 5 spotted. And then we have 7 of the yellow ones are spotted. So the yellow, 7 spotted. And then we have 2 of the red marbles are spotted. So of the red, we have 2 spotted. Okay, I'm writing all that information down, and you should also, because we're about to scroll down and then we're not going to be able to see the question anymore. Okay, we want to pick a marble at random. What's the probability that it is a yellow and spotted? So let's go down. And let's pick A. So we want the probability of, I'm going to write Y and S. Any questions on that so far? Oh, you know what? Can you see? Yeah, I just want to make sure that you can see what I can write. Okay, any questions on so far on that probability? Okay, so probability, as I mentioned, probabilities are fractions, right? So we need a numerator and we need a denominator. Let's do the easiest piece first. What is the denominator? So what's the denominator of this one?
42.
42. There's 42 marbles. Okay, so it's going to be 42 on the bottom, and the top will be the yellow ones that are spotted. And what was given to you is that 7 of the yellow ones are spotted. So that's just going to be 7 over 42. Any questions on part A? There's not much work to show other than, like I said, it's very important to write it in symbols at P, parentheses, Y, and S, and parentheses. That's kind of, work you can show. Okay, so now B. So B is if you pick a marble at random, what's the probability that it is spotted or blue? So what we want is a probability of spotted or blue. Now there's a formula for that. So when you have an or probability, that's a probability of spotted, probability of S, plus the probability of B for blue, minus the probability of spotted and blue. Any questions on this formula? Okay, so now it's a matter of counting. Notice the denominators, no givens here, so the denominators are all going to be 42. So we can put it all over the same denominator, and we just count. So the first is how many spotted are there? And this was given basically. How many spotted marbles were in the bag? And again, if you wrote down all the info, then you should have it. Okay. Notice there of the blue ones, 5 were spotted, yellow 7 were spotted, red 2 were spotted. 5 plus 7 is 12, plus 2 is 14. Okay, any questions on that? Then we're going to add the number of blue marbles. How many blue marbles were there? Yeah, that was in the
15.
info. Yeah, 15. And then we're going to subtract the blue spotted marbles. Okay, the spotted blue ones. And it was given that there were 5 of those. And we have to divide that by 42. And again, it's just basic arithmetic. 14 plus 15 minus 5 is 24. Okay. And I don't make you reduce the fraction. If you want to put a decimal, you can, but I think fraction's easier. Just write it this way and you're done. Any questions at all on part B? Okay, let's do C. C is, are being read and being spotted mutually exclusive? So remember we had a definition of mutually exclusive. That was the probability of, so we're looking at, again, red spotted. So probability of R and S. If they're mutually exclusive, what must that probability be? Zero. But there were 2 red spotted ones, so that's going to be 2 over 42, which is not equal to 0. So not mutually exclusive. Any questions on part C? Okay, so now we go to part D. Are being blue and being spotted independent? Back up your answer numerically. So we're looking at blue spotted. So that's D. And there's different choices. So if we look, for example, what is the probability of being spotted given blue? And the question is, I'm going to write equal with a question mark because that's what we're going to try and find out. Is that equal to the probability of being spotted? Any questions so far? Symbols make me lose confidence in my understanding. As I'm doing statistics and probability, odds are about things. So you need to have the symbols down. I know you don't like them, but you need to learn the symbols because that's how I'm going to give you partial credit. So it's very important to have the symbols. The best thing you can do is practice. Practice, 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 and more practice. Yeah, that's all I can tell you is practice. And then the symbols won't be a big deal. It's just like learning a foreign language. At the beginning, it's really hard. But then once you start practicing a lot, then you just talk. Okay, and similarly with the symbols. Okay, so that's my suggestion is practice. And again, they're going to make your brain hurt until you practice a lot, and then pretty soon you're just familiar with it. And I'm giving you lots of examples, so use the examples. You can practice redoing my examples. Okay, so let's do spotted, given, blue. Well, of the blues, there were 5 that were spotted. Well, there were 15 blues. So spotted, the probability of spotted given blues are going to be the number of spotted that are blue divided by the number of blues. And the question is that equal to the probability of being spotted? Okay, well, how many spotteds are there? We had 5 spotted blues, 7 spotted yellows, and 2 spotted reds. So 5 plus 7 plus 2, we've actually already done that. That was 14. Over 42 total, no given on the right-hand side. Are those numbers equal to each other? Are those fractions equal? What do you think? Okay, and you don't have to do fraction arithmetic. You can just pop it in a calculator if you felt like it, but you have to know how to do it. So if you put it in a calculator, that 5 over 15 is 0.33333, a bunch of threes. And is that equal to, and if you do 14 over 42, that's also 0.3333, a bunch of threes. Okay, and the threes go on, by the way. Are those equal? This should be an easy answer, by the way. Are those fractions equal? Yeah. So since they're equal, being spotted and being blue are independent. Because that's what it means to be independent. It means that any of the 3 equalities are true. And I grabbed this one. This seemed to be the easiest, and that one's true. If you use the other ones, you'll get equality also. Okay, let's do E. So E was if you randomly pick 2 marbles with replacement, what is the probability that the first will be yellow and the second will be blue? Is that clear? So first is yellow, second blue. Okay, and notice the key word here, and is an important word. So we want the probability of the first is yellow. I'll just use Y1 for yellow first. And the second is blue, B2. But here's the nice thing. This is really important. And we talked about this a couple days ago, is notice that in E, it says with replacement. So when you have with replacement, then what you can do is you can say they're independent. With replacement's always independent. This is the probability of Y1 times the probability of B2. So what's the probability that the first is yellow? And this is a matter of counting, basically, or given the count, finding the count. So notice that there were how many yellows? I don't see y'all answering, but hopefully this isn't supposed to be that hard since it's given in the question, as long as you were writing as I was writing. So how many yellows were there? Okay, yeah, there are 18 yellows and divided by 42 marbles. And then you got to multiply by the probability the second is a blue. So what's the probability the second is a blue? Yeah, 15 over 42. Okay, and this is when you'd probably want to use a calculator or a computer calculator for it. So I'm going to do that. I'll just pop it in. And it gives about 0.153. Any questions on E? Okay, let's look at F. Okay, so if we look at F, F is if you randomly pick two marbles without replacement, and that's important. Notice the last one was with replacement. This is without replacement. What's the probability that the second one will be yellow? Okay. So that means we just want to find the probability of Y2. So what is that probability? Okay, this is a little tricky. Okay, so we want to find the probability the second one is yellow. If I just say that, are there any marbles that you can rule out? You can think of the marbles as 1 through 42. Are any of those ruled out? Are there any that you know of that you can actually specify? And the answer is no. So there's actually 42 different possibilities. So it's going to be 18 over 42. Any questions on that? What I found is most people get this wrong. I'll find out when I grade the quiz, but this is the time to get things wrong. The test is the time to not get things wrong. Let's do part G, that's the last one. You randomly pick two marbles without replacement again. What's probably the first will be red, the second will be blue. So let's write symbols, probability of the first is red, I'll call that R1. And the second is blue, B2. Okay, so to get that one, that's equal to the probability that the second is blue times the probability that, the probability the second is blue given the first is red times the probability the first is red. Okay, that was a little formula we had. Okay, what's the probability the second is blue if you know the first was red? So that's going to be 15 out of 41. So unlike part F, in part G, we're given knowledge about the first one, whereas in part F, there's no given. If there's no given, the denominator never changes. But if there's a given, we got to change that denominator. Okay, then we got to multiply by the probability the first is red. Probability the first is red. Let's go times. Probability the first is red, there are 9 reds out of 42. And again, you can just pop that into the calculator. And we get 0.078 about. Okay. Just a note on these quizzes, since I grade them by hand, you can get away as long as you do rounding correctly. You can go as many decimals as you feel like it. But on the regular homework, the homework that you have to submit online that's graded by the computer, you got to follow the instructions on decimal places. Any questions at all about the quiz? Any questions? Okay, if there's no questions, I'm going to finish off. And we're going to take a look at these. Okay, so let's look at number 5. So we're finishing off from last time. And we're going to do some more examples. So you roll 2 6-sided dice. So hopefully you all know what a die looks like, right? It's cube, and there's 6 sides of it, and each one is equally likely. And they're labeled 1, 2, 3, 4, 5, and 6. Let A be the event that the first die lands on a 4. B be the event the first die lands on an odd number. C be the event that the sum of the die is an 11. Should be an 11. And D be the event that the sum of the dice is a 7. Okay. What are the, which of the following are mutually exclusive? So let's start with A and B. So the probability of A and B, well, A means the first was a 4. B is the first is an odd number. What's the probability of rolling a die, rolling 2 dice, and the first is a 4 and odd? What is that probability? Zero. If you rolled a 4, it's not odd. So since it's 0, what's the answer to part A? Part A, first one. Yeah, and I'm going to abbreviate. I'm just write ME for mutually exclusive. Less writing. Let's do number 2. Probability of A and C. So A is the first die is a 4, and then C with the sum is an 11. Okay. Well, if the first is a 4 and the sum is 11, what must the second one have been? A 7. Can you roll a die and get a 7 on a single die? Yeah, it's not possible. That's 0, so that's also mutually exclusive. Any questions on that? Let's do A and D. So the probability of A and D. So let's read it again. A is the first die is a 4. D is the sum is a 7. Can that happen? Yeah, because you can get a 4 and a 3. And that's actually the only way it can happen. That probability is there's one way of it happening. How many different die roll possibilities are there? How many events are there total? This one you have to think about a bit. So here's a hint. How many events are there for the first die roll? Just the first die. How many different events? How many different possibilities are there for that first die? There's 6. Okay, and for the second die, there's also 6. So for each of the first die, there's 6 of the second. So 6 times 6 is 36. So the denominator is 36. That is not 0. So what's the answer to part 3 on A? Yeah, not mutually exclusive. And I'll use ME, it's less technical. Any questions at all on part A? Okay, let's look at part B. Which of the following are independent events? Okay, so first thing, A and B. So to find out if they're independent, we have 3 choices, right? We can look at the probability. Remember, A is the first is a 4, B is the first lands on an odd number. So we could look at the probability of B given A. Okay, and that probability, well, that means that we're told the first is a 4. Now that we're told that, what's the probability it's odd? Zero. But the probability of B is just the probability that we have an odd number. Okay. Well, an odd number can happen with a 1 and a 2 and a 2 and a 1. There's a whole lot of different ways for an odd number to happen. And you can count them out. Maybe I'll count them quickly. There's 1, 2, 2, 1, right? There is 1, 4, 4, 1, 2, 3, 3, 2. Okay. Then there are, I'm going to tell you there's 6 more that are 7. So it's large actually. Okay. So I'm just going to not is not equal to 0. That's really what matters. So they are dependent because they're not the same. Any questions on part B? 1. Okay, let's do part B2, A and D. So A is the first die is a 4. D is the sum is a 7. So there's different ways of doing this one. So how about the probability of D given A? Well, if the first is a 4, then the way to get a 7 is the second better be a 3. Okay, there's only one way of that happening out of 6 possibilities for that second die. Whereas the probability of D, that means that the sum is a 7. So you got to count the 7s. We could have a 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, and 6, 1. There's 6 different ways for that to happen. And we already saw that there were 36 different paired dice roll. So what do you think? Independent or dependent? Did we get the same answer or not? So take a look, you tell me. Okay. Yeah, these are independent because 6 over 36 reduces to 1/6. And you're welcome to put in the calculator and get 0.1666666 forever for both of them. So these are independent. Okay, then finally, let's do B and D. So if you remember, let's go down and see what B was and what D was. B is the first is an odd number. D is that we have a sum of a 7. So we want to find out, again, there's a lot of different ways of doing this one. So we can say the probability of, how about B and D in this case? I'll do the other one because I haven't done one of those. And we want to find out what that is, and then we're going to multiply the probability of B times the probability of D. So if the first is an odd number, then what's the probability that you get a 7? Okay. The idea is it doesn't matter which odd number you get. There's exactly 1 out of the 6 choices for the second die roll that will give you a sum of a 7. You start with a 1, then that would be a 6 that you would need. You start with a 3, that would be a 4 that you need. You start with a 5, that would be a 2 that you need. So that's going to be 1 out of 6. So let's take a, actually B and D is we need both of those to happen. We need it to be odd and we need it to be a sum of 7. Does that make sense? Okay, so I actually did D given B. Maybe I'll do it that way, because that's the one I just talked about. The probability of D given B is going to be 1 out of 6. If you know that you have an odd number, you have a 1/6 chance of getting a 7. On the other hand, the probability of D, well, we just did that. That was 6 over 36. So what can we say? Yeah, they're independent. Okay, so I figured I'd independent. I figured I'd give you an example of die roll because everyone should know what a dice looks like. What a die looks like. Now comes the next one. Okay. So This is what's called a contingency table. A contingency table basically means that you have two survey questions or two variables, and the numbers in the table, for example, 23, tells you that there were 23 people who were driving an economy car and shopped at Raley's. Okay, so that's what that means. Okay, so we have a contingency table, and they asked them what market they shopped at and what kind of car they drive. And this is how you read that table. Any questions on that? Okay, so now what we need to do is you need to find some probabilities. So let's find the probability that the person shops at Raley's if we pick a randomly selected person. So what I'm going to do is I'm going to write P of R for Raley's. Well, that's going to be the number of Raley's shoppers divided by the total number of shoppers. Any questions on that? So how many Raley's shoppers were there? Okay, 102. So again, you can stick in a calculator, whatever it takes. 5 and 3 is 8, and 7 is 15, and 7 more is 22. Carry the 2. 2 plus 2 is 4, and 5 is 9, and 1 is 10. You get the 102. Divided by the total number. And it, by the way, it might help to kind of below this. I'm going to write 102. And then over here, let's find out how many Safeway shoppers there were. So we got 35 and 62 is 97, 99, 109, 118. And then grocery outlet shoppers, 48 and 14 is 62, and 11 is 73, and 16 is 89. So our total is the sum of those. And that's going to be, well, we got 220 and 89 is 309. If I did all my arithmetic in my head right, you're always welcome to use a calculator. So in particular for part A, we just divide by, what do we divide by? Yeah, 309. And that's it. Any questions so far? Okay, find the probability that a person is a Safeway shopper who drives an economy car. So I want you to put in the chat box in symbols. That's usually the hardest part about these kind of problems, is how do you write these in symbols? So what is this one? See if you can put in the chat box in symbols the probability that a person is a Safeway driver, a Safeway shopper who drives an economy car. See if you can put those in symbols. The hint is the first letter you should write is P for probability. So again, I could tell you how to do it, but it's better if you try it yourself. This isn't supposed to be that hard. And I'm waiting a couple people to see if they agree or not. Okay, so we got some different thoughts. Okay, so if someone is a Safeway shopper who drives an economy car, I'm going to get rid of some of this other stuff so that we can have it on the same page. There we go. If someone is a Safeway shopper who drives an economy car, are they a Safeway shopper? What do you think? Yes or no? Are they a Safeway shopper? Yeah. Do they drive an economy car? Yes. We're not told anything about them. This is just probability of Safeway and economy, because they both have to be true. If both have to be true, and we're not told something, then it's an and problem. So now what we do, it's very easy. We go to the table and we say there were 35 people that shop at Safeway and drive an economy car. So the answer is just 35. There's no given, so the denominator is always going to be the total, 309. Do I make it easy? Did I make it look easy at least? Okay, part C. If the person shops at grocery outlet, find the probability that the person does not have a car. So again, I want you to put that in symbols. I'll start you off, P parentheses, and you do the rest. Give you a minute. See if you can put that in the chat box. So it's if the person shops at grocery outlet, find the probability that that person does not have a car. Let's see a couple people try. At least maybe everyone try, they'd be better. Okay, so you know it's a given problem. Let's see what we're given. What are we told about the person? We're told that they shop at grocery outlet, so the given is G, and we want the probability of not having a car. So I'm going to write N, and then the little vertical line segment G. Okay, so most of you got it, which is good. Okay, so to find that, what we're going to do is we go back to the table. And actually, before that, I'm going to write down the formula. That's the probability of N and G divided by the probability of G. And the idea here is that both of these, the probability of N and G and the probability of G have the same denominator. So the denominators cancel. We can just look at the counts. And the N and G, there were 16 of them. So 16 will be the numerator. Probability of G, those are the grocery outlet shoppers. There were 89 of them. So that's over 89. And that's good enough. If you're doing this on, on the computer with the computer graded stuff, you'll probably have to put it as a decimal, but read the instructions. Okay, next, find the probability that that person shops at Safeway or drives a sporty car. So again, that's P of S or, let me write SA because sporty starts with an S also. SA or SP. Any questions on that? But that's the probability of SA plus the probability of SP minus the probability of SA and SP. Whenever you have an or, you can always write that equation. So now we go to SA. And notice, by the way, there's no given, so they're all going to have the 309 as a denominator. So if we go FA, Safeway, there were 118. And then we got to add the SPs, sporties, and there were 12 and 17 is 29, and 11 is 40. So 40, 40 incentivize. And then we got to subtract the Safeway Sporties. And there were 12 of them. And that's divided by the 309. And again, you're welcome to use a calculator, but I'm just going to do it in my head because I can. 118 plus 40 is 158, minus 12 is 146. So it's 146 over 309. Any questions on part D? Any questions? Okay, let's go to our last one. Okay, the funny thing is I wrote this one last time, or I popped it up last time, but this one has meaning today and this week because I wrote the example beta today. I'm going to do the lake on Saturday. We'll see. I'm going to go around the whole lake. So suppose that 65% of customers who walk into a bike shop actually purchase something. Okay. By the way, I think bike shops are all closed now. I think they're not essential, but eventually we'll be able to walk into a bike shop. The manager has noticed that 35% of all customers walk into the bike shop alone. Of those who walk into the bike shop alone, 70% purchase something. Okay, so what I recommend doing in these kind of problems is before you even answer A and B, I think there was an A, B, and a C maybe. Yeah, A, B, and C. Let's write down the givens. What did they tell us? So we have 65% who walk into the bike shop purchase something. So we know the probability of what? So in symbols, how do we take that 65% and write it in symbols? See if you can put that chat box. See if you can write that in symbols. And you should all be doing this, not just one or two of you, but you should all be trying. Because again, if you don't try, you don't learn as much. So 65% of customers who walk into the bike shop purchase something. So what is that? So it's just over the P, whatever you got. It's always P of, since it's a probability. Because this is the hard part about this chapter, is to be able to read a paragraph and then decide what probabilities is that paragraph giving you. Okay, so P of C. Okay, you could use C, but I'm going to use, we're talking about purchasing something. I'm going to use B for buy, B-U-Y, because that's the same thing as purchasing. P is a bad letter to use for probability because that's already been used. So P of B is equal to 0.65. It's not a given because this whole thing is about our customers. Okay, then the managers noticed 35% of all customers walk into the bike shop alone. With that in symbols. So it should be something equal something. That's a hint. Yeah, so P of A for alone is equal to 0.35. Okay, then of those who walk into the bike shop alone, 70% purchase something. What's that the probability of? Write that in symbols. Yeah, that's the probability of, what is it? I think you might have it, but you typed it a little wrong. B, horizontal line segment, which means given A, is equal to 0.7. If you could do this, none of these problems are hard, but you have to be able to read a paragraph and write the symbols. If you can't do that, you're not going to be able to answer these questions correctly. Okay, so now let's read part A. Find the probability that a person who walks in the bike shop will walk in alone and purchase something. What's that the probability of? Yeah, that's an A and B, because they have to do both to be counted. Well, we don't have A and B exactly, but what we do have is we have B given A. And we have a formula. That's the probability of B given A times the probability of A. That was a formula for and probabilities. And then you just plug in, because we've already got it written. That's 0.7 times probability of A was 0.35. Any questions on that? And we'll finish this off. Again, you can use a calculator on that. That's going to be 0.245. I did it right in my head. Any questions on part A? Part B. Find the probability that a person who has purchased something has walked in alone. What is that? That's P of what? Yeah, that's going to be A given B. And we have a formula for that. That's the probability of A and B divided by the probability of B. And the nice thing is we have those. The numerator we just did, 0.245. And then the denominator is the probability of B, which was 0.65. Any questions on this so far? I want to let you know something. This is really important. Maybe even write this down. Is that when I give this on an exam, those who correctly write this part down, I'd say about 80% get it right. Those who don't, it's usually not even 10% get it right. So what do you think you want to do on an exam? Yeah, you want to start out by writing out all of the givens in symbols and practice, practice, practice so you learn how to do that. Okay. So find the probability that a person who walks into the bike shop will not purchase anything or has walked in with another person. What is that? What's that the probability of? I don't see y'all jumping in. So that one's going to be not not B or not A, because they did not purchase anything or they were not alone. Okay, so now what I'm going to do, and I haven't given you an example of this, so it's time to. We're going to use what's called the rule of complements. We can write that as equal to 1 minus the probability of the complement of what happens if this is not true. So if it's not true that the person did not purchase anything or walked in with another person, what do you know happened with that person? So if the statement not B or not A is false, what does that mean? And the hint is, as soon as we get it, it's going to be really easy, but you have to be able to kind of think this way. That's the hard part about these problems. The math is really easy. What's hard is reading that question and coming up with the logic. So if we have not B or not A, that means B must be true and A must be true. So that's B and A. Any questions? Anyone lost on what I just wrote down? And the idea is, this is the rule of complements. So example, if you have 90% chance of winning, what's your percent chance of losing? 10%. So that's called the rule of complements, is you always subtract from the 100%. And we typically use not percents, but decimals, because calculators handles that a lot better. So we use 1 instead of 100%. Okay, so that's what this is. Any questions on this? Then it's really easy. That's just 1 minus probability of B and A. That was the same as the probability of A and B, which was 0.245. Any questions at all on that? And by the way, you can do this as what, 0.755. I did in my head right. Any questions on part C? Okay, so I want to warn you, these are a lot harder to do than to watch. So it's one good thing to come to the webinar and, look at what I'm doing and shake your head, but it's much more important is to try your own problem. And there's a lot of them. There's a lot of them on the homeworks that you're gonna have to do also. Okay. Now what I want to do, I want to spend the next bunch of time. I have to leave in less than half an hour or so. So we should have plenty of time. So I want to talk about the project. So let me go and I want to show you how to find it. There's a few ways of finding it. So I think the easiest is maybe go to the syllabus and scroll down until you see projects. Okay, so 2 projects will be created for this class. Okay, project 1, and by the way, if I scroll up, project 1 is due April 28th. Okay, and if you do the math, today is the 16th, so the 28th is a week from Tuesday. That should be plenty of time if you get to it. Don't wait till the last minute because it's a lot of work and you won't make it in time. So that's the first thing. A week from Tuesday is when it's due. Now I'm going to read a little more. Okay, you can use a computer to do charts and statistics, basically. Okay, I want to highlight this guy right here. A 30% penalty will be incurred on any student who cannot work with another student. Okay, and that is non-negotiable. So in other words, you basically cannot pass if you work alone. So do not work alone. Okay, and I talked about at the beginning of this webinar, to find a project, you go to the Project One discussion board. You say, please join me in a group. Okay, or find someone else that said that and say, yes, I'll join you. Okay, very, very important. Okay, so let me give you a little timeline on the project. So the first thing you should do and should have already done, and that is find a project. That was number one. Number two is come up with your idea of the project. Okay, and that when I say you, I should really say y'all, because you and your partners, y'all have to agree on what you want to do for your project. So come up with an idea for your project. So then once you've come up with your idea for your project, then you want to post on the Project One discussion board what your idea is. And I'll take a look at it and I will comment on whether I'll say, yes, this is great. I look forward to reading it. More likely, I'll say, this is a really good project, but here's a couple things that you might want to think about to adjust so that this will work out for you. Okay. And then occasionally I'll say, no, this won't work. Think of a different one. But usually it just needs adjustments. That's typical. And the other, so the reason why I want you to put in the project discussion board and not email it to me is that way everyone can see some different ideas. So you can find out what works and what adjustments need to happen. And then pretty soon you'll get an idea of what a good project looks like. Getting data won't be easy. Well, it might, because I'm going to talk about it. We'll get there in a minute. Okay. I don't think it's going to be that hard. It's going to be different though. Okay, but of course, different doesn't mean anything because for most of you, this is the first time you've ever taken this class. You have nothing to compare. But I'll talk about it in a minute. Okay, so that's the main thing. Then once you have posted your project idea, and I've said great, or I've said here's a couple changes, and you know you're going to change them. Then you go out and collect your data, and we'll talk about that in a little bit. Once you've collected your data, you put it into the spreadsheet program. Can't be done on a calculator. It has to be done in the spreadsheet program. Okay. My recommendation is use one I wrote because I wrote it for this project basically. But if you want to use a different one, that's okay. But it needs to be a spreadsheet program that has all the stuff the project requires, which I'll get to in a minute. Okay. Then the next thing you do in the timeline is you do your write-up, your draft. Talk about why this is important, what decisions your client will make based on it, and just do the whole write-up. And when I say you, it's y'all, you know, you and your partners, make sure you all read it together. Most people find Google Docs is a good way of doing it because then you're all on the same page. Okay, I'm not gonna say you have to do Google Docs, but most people find that's an easier way. Then what you wanna do is 48 hours before it's due. Okay, even better is more than 48 hours before it's due, but that's the absolute last chance. So that will be, again, it's due on a Tuesday, so that'll be a Sunday. Okay. 48 hours before it's due, you email it to me, and then I'll give you feedback. And then that'll give you a day or two. I'm usually pretty quick about giving feedback. I mean, if you're all sending it that last minute, then it might take me time. And I give feedback at a first come, first serve basis. So whoever sends your draft first, I look at it first and they get the first feedback. So if you wait till the very last moment, you know, exactly 48 hours before it's due, it might take me a while to read your project. It takes a while to read these projects because they're pretty long and there's a lot of you. So just to let you know. Then once I give you feedback, I will email you back. You share it with your partners. Then you address the issues, the feedback that I've given you. And then you submit it in Canvas. Okay, so do not submit your draft, only submit your final copy. So that's kind of the process, the timeline. And again, notice 48 hours before, that's a Sunday, so over that weekend, you want to send in your project to me. Okay, it could be a little before the weekend, that's fine too, Thursday or Friday before. So, you know, realize that you need to start right away so you can get this done. This takes time. Okay, if you click on project 1, I have a list of things to do. So the first is think of a quantitative investigation that someone might contract out to have done. Okay? And that someone, you need to identify the someone. You don't have to really find someone who's going to pay you, but at least theoretically someone who might pay you. Okay? Then perform the investigation and produce a report as though you were handing the report to the person paying for your services. So the audience of your project is not me, it's this client that you have. So that's who you should be addressing the project to. Any questions on that? So you need to identify in your project who the client is and address the whole way. Okay, next, the purpose of the project, of the report, is to make recommendations based on your findings. Okay, it's not to define statistics, it's to make recommendations. And findings mean the statistics. So based on this statistic, here's something you as a client might want to do to improve your business or improve the college or to improve the government or whoever your client might be. Okay. Okay, any questions so far? Okay, in your project, you must include a description of the sampling technique that was made and how the technique was applied. You can use either simple random sampling, and I want to warn you, this is almost always impossible. So if you think you use simple random sampling, you probably didn't, and I'll take off points. Okay, so you better check in with me if you really think you can, because you probably can't. Or you could use stratified sampling. So stratified sampling we did last week. Or you could use cluster sampling. Okay, again, that was all done in the first day of class. Those are your two choices, basically, stratified or cluster. Because people have trouble with these, I have a link. I'm not going to read through all this, but here's some notes about stratified sampling. Okay, I'm going to let you read through that so that you get an idea of what the sampling is. And I also have a link to cluster sampling. Okay, discuss any bias that might have occurred due to your sampling technique. By the way, if you think that there is no bias, good luck convincing me. Okay, it is pretty much impossible to have an unbiased study. Okay, so bias means it's a misrepresentation of the population so that the sample data will not represent the population data. Okay, so either the sample mean will be too high or too low because of the bias. So I want you to discuss whether you think it's too high or do you think it's too low. Okay, based on the bias that you should identify in this paper. Okay, the variables must be quantitative. Do y'all remember what quantitative is? What does quantitative mean? Who remembers we did this last week?
We can count it using a number.
Yeah, now, I wouldn't say count. It means that you can, the answer will be a number. So here's what I recommend you do. You're going to write down your survey question. Ask your partner the survey question. If the partner says yes as the answer, this will not work as a project. If the partner says 23 as their answer, then you got a good shot that this is going to work. Does that make sense? So think about the survey question and what the answer to the survey question might be, and it better be a number. That's an absolute requirement. Okay, the sample size must be greater than 30. We will learn in a couple of weeks why 30 is really important. Right now, you just gotta trust me that that's an important number. So you must have more than 30. All right, because here's what you're not allowed to do. You're not allowed to break the law. Okay, so you can't touch anybody. Do you know why? Unless it's your wife or husband or something like that who you're living with, I guess. Okay. And why can't you? Can't even get close to anyone. I don't see anyone jumping in. Yeah, we have a quarantine, which means that just about every one of you will be doing this as an online sample. Okay, so you can do online sampling. So you could either use Stratified or Cluster. Online sampling, I'm telling you, it's not going to be possible to do simple random sampling. So Stratified or Cluster. And so you're going to identify the Stratified or Cluster. You're going to make that process. Then you're going to email or message people with whatever social media thing you got and beg them to answer your question. They probably will, especially if you know the people, especially if you say, I'm in a stats class and I need this for my project. Don't let me fail this class. And they'll all help you. Don't you agree? So all you have to do is give me the number to the answer to this question for you personally, and and let them know that it is that you're not going to like tell everyone in the world about that person's answer. Okay, so it shouldn't be that bad. Again, if there's 3 of you, all you have to do is email 11 people each to look at it that way. That's not too bad, is it? Okay, that shouldn't be too bad. So you're probably going to have to do this one virtually because this class has become a virtual class. Okay. Any questions on sampling? Okay, so then you must include all the charts. So you must include a histogram. You must include a stem and leaf. And you must include a box and whiskers. Okay. If it's relevant, you can include other charts, but these 3 must be there. And okay, so how is email not convenient sampling? Well, you could do it with stratified sampling. So let's say you stratify by gender, and you have to identify who your population is, find out the proportion of men and proportion of women, and then you email that many men and that many women. Do you see that? And it's not pure convenience sampling because it's stratified sampling by gender. Does that make sense? Okay. And again, it could be gender, it could be ethnicity, it could be race, all kinds of things you can stratify by. Or you could cluster sample. Cluster might be a little hard on this one. There will be bias. Remember, I told you up here. Discuss any bias that might have occurred to your sampling technique. And I said, if you think you don't have bias, you're wrong. There's always going to be bias. Every study has bias. The hope is the bias isn't so miserable. But yeah, there's going to be bias. Okay. And so I do not grade on whether you have an unbiased study. I grade on whether you have identified the bias. Do you see the difference? Okay. If you want to almost complete unbiased study, it's probably going to cost you $50,000 to do that study. And I'm not going to make you pay that kind of money because that'd be silly. Okay. But I am going to make you identify the bias, okay, in some sentences. Okay, so you must identify all the charts, okay? And you must use a spreadsheet program and not a calculator to make the charts. Any questions on that? Okay, I want to mention something. Yeah, we got time. We got about 10 minutes. Let me get into this. Just a bit. There it is. So this is a spreadsheet. Column A is going to be where you put your answers. Remember, your answers are all numbers. Is that clear? Okay, you're not doing a comparison study. There is just going to be one column. If you're stratified by gender, it does not mean you're doing men versus women. It just means that you have the right number of men and women, and they all go in column A. You're not comparing men and women. You're just making sure you don't have gender bias. Okay, or if you're doing based on race, you're not doing different races in terms of comparing them. You just want to make sure you don't have racial bias or whatever you're doing. Okay, you can do age, whatever you're doing with it. That's just that you're only going to have column A, and it should be a bunch of numbers. Okay, the histogram is just shown here. To get to the other charts, if you go stats, you'll see there's a box plot, and you just click it. Now, when you click it, more than likely, you're going to get all these warnings about a virus. And I promise you, I did not put a virus on my program, but your computer will think there might be one, and there really isn't. You can trust me. I wouldn't do that to you. Okay. So you're gonna have to do all kinds of I trust this kind of thing. There's also stem and leaf. And there it is. And so this is, right now it says the S and L left is 10 power 1. So it just means those are tens. If you want it to be hundreds instead of tens, you change that 1 to a 2, because 10 to the 2 is 100. Okay, and you can change it to what you want, but it should be reasonable. Okay, in case your computer doesn't let you do the stem and leaf, what I have done is, these are supposedly links. At least they were once links. Let's have a look at this. Okay, these are links to stem and leaf, box plot with data and 5-point summary. Oh, there it is. Sorry, it's not these guys. Okay, again, in case this is not working for you because your computer is like so freaked out, I might give you a virus. These guys are okay. These work. Okay, any questions so far? Okay, and by the way, this also gives you the minimum, the mean, the sample variance we don't really do in our class, so skip it. Sample standard deviation, that's the biggie. I'll talk about that in a minute. Median, maximum, Q3, and Q1, and there's the Z-score. And if you just put 69, that's not good, okay? You better understand the Z-score. All right, so let's continue on. Here. You want to interpret the charts and discuss what each chart says and does not say about the population. Compare and contrast and state what audience each chart might be best for. And you should always be talking about the recommendations you are going to be giving to the client based on the charts. That's the whole point of this paper. Okay, a list of summary statistics. That is the mean. You can list the variance, but don't try and interpret it. The standard deviation. So for example, if you asked, I don't know, how much money did you spend on food this week? And the variance was, 4,000. The units are square dollars, which are meaningless. And that's why it's best to just skip variance. Okay, and there's a bunch of other stats. Now read this. Pay special attention to the standard deviation. Okay. Projects without at least a full paragraph on the standard deviation cannot receive an A. Okay. I take off lots of points if you didn't. In particular, is the empirical rule appropriate, or must you resort to Chebyshev's theorem? I want to look through the book and read about that. Okay, what does the rule or theorem say about your population? And of course, based on that, what recommendations are you going to make to the client? Discuss how to use a Z-score for the study. Okay, so we talked about that on the quiz a few days ago, that you had to do that. Make sure you interpret all statistics in this project in the context of the survey, that rather than just list definitions. The definitions are not important. Okay. And it's a paper, so you should have an introduction, you should have a body and a conclusion. So that's the synopsis stuff. You should include recommendations throughout the paper. Okay, so don't just give vague recommendations. If a different number would have, if your recommendation doesn't include the number you're talking about, and you're not using that number, then it's not a good recommendation. So an example I've got, let's suppose your study was on age that students first learn the quadratic formula, and the mean was 15.3. Here's what you shouldn't say. Don't just say the mean could be used to understand when people learn the quadratic formula. Because notice that doesn't use 15.3. Instead, you would say students are learning the quadratic formula on average just after they turn 15. Based on this, high school should be leery about moving chemistry, which requires this knowledge, to the freshman year. So now notice we used the number 15. You see? And here your client might be the principal of the high school. Does that make sense? So all of your recommendations must be recommendations based on the number that you got for the statistic. Okay. And also talk about how you would develop the project in more detail, more depth, better sampling, had you had more time and resources. Okay, just a note, I have a link here. This is some feedback that I've given to other people who sent their drafts to me. So I have a bunch of stuff. I recommend reading them so you know what to avoid. I'm not going to read through all of it, but you can. Okay, any questions about the project? I'll let you read through the rubric also and the learning outcomes. Any questions at all about the project? We have a couple more minutes left, and then I have to go and give that presentation to probably 100 California professors who all want to figure out how to give free books out, how to make it free. So any questions? Any questions? Again, we have a few more minutes. If you have questions, I can answer. Okay, so I recommend getting together with your partners today and talk about it, get an idea, maybe even tonight, post your idea on the Project One discussion board, and I'll start talking about it. And that way you're not waiting till the end. This takes a long time, this project. Don't wait till the end. So get to it is my biggest suggestion. Anna can help also, right, Anna?
Yes, I can help.
Yeah.
I'll be available to help everyone. And today after class, I'll be there from 3 to 6 since class is finishing early.
Okay. So, and she definitely can help. She knows about my projects. She was my embedded tutor 2 quarters ago, so she went through this already once. And I haven't changed anything other than you're doing your surveys online this time. That's the only new thing, and well, that's called life now. Our new reality. I'm hoping in fall we can go back. Don't y'all hope so? We can actually hug each other. Okay, if there's no questions, then I think I'm going to call it a day and then get to this big presentation I got to do. And then Tuesday will be normal time. You know, I don't know if we'll need the whole time on Tuesday, but I don't think I'll be in person. I'm hoping it's going to be in person. I'm hoping they find a cure. Let's be like optimistic and hopeful. We can always be hopeful. I'm not saying I'm planning on it, but I can be hopeful that maybe they'll find a cure and that's it. If they find a cure, you take a pill. If you have it and you're better, done. Let's cross our fingers and hope it can happen, right? Okay, might not. Okay, so that's the hope. Okay, and lots of people all over the world are working on it, so hopefully. Okay, well, I should get going because, again, I'm going to be giving this lecture to over 100 people, trying to get them to make textbooks free for all colleges. So that's my goal. So I'm going to end this meeting and close out the meeting. So you're about to get shut down. So thanks a lot. And after an hour or so, after a while, I'm going to be checking my email a lot and reading that Project One forum board to make sure that I can answer your questions. Okay, so take care.